And we'll just do 2b now. And my brain played tricks on me in the last question where I made a mistake. This question is designed to make your brain trick you. Okay? First of all, cotangent, we're going to learn that on our calculator we have degrees and radians. So whichever calculator you have, we need to switch it. So right now we've been doing questions, every one of your calculators should be in degrees. The only reason it wouldn't be in degrees is if you have not been working along with us and not doing your homework. So don't say, oh, mine was already in radians. I'll know if you haven't been doing any work. Okay? On a graphing calculator, you can hit the mode button, and then it lets you switch between degrees and radians. I just highlight radians, and now if I go second quick, my calculator's in radians. Sometimes it even shows up at the top. Lots of calculators show up at the top. A D for degrees, R for radians. So we need to change to radians. Next, once you change to radians, now you can do your math the same as you would with degrees. Okay? So we've done questions like this before. Determine the value of cotangent 12 pi over 5, but you don't have a cotangent button. Right? If this said tangent, you could just type in, right? If this was a tangent question, I would just type in tangent of 12 pi over 5. I type that in exactly as I see it, and my calculator gives me the right answer using radians. Tangent is opposite over adjacent, so if the angle was 12 pi over 5, the opposite side would be just over 3, and the adjacent side would be 1. That's what that number means. Now you have to do cotangent of 12 pi over 5. And at this moment, you want to check if your brain plays tricks on you. Because I'm going to give you this question on a quiz or a test, and you're going to type something in, and we're going to get different answers. Okay? And there's lots of different answers that come up. So, find out what answer you get on your calculator. I'm going to try and think of all the ones that people could do if they did something wrong. There's so many little tiny mistakes that you could make on this one. Okay. The right answer is 7.56. Wrong answers could include, but are not exclusive to, let's see. Did anybody get close to 432? That's a common one. Anybody get close to 0.0002? Or other possibilities of things going wrong, 43 or 0.2? The answer you should get is 7.56. If you didn't get any of those answers, you obviously are doing an additional thing wrong. Okay? Now, what happens here is your brain is playing around with reciprocals and mixing up things with the ideas of reciprocals. The definition of cotangent is that cotangent of theta is 1 over tangent of theta. It's reciprocals, okay? And with reciprocals, we often flip fractions. But we flip fractions, just a review of reciprocals, we use the shortcut where we flip fractions, but we use that shortcut if we knew ratios. So your brain knows the following. If I know that tan of theta was 13 over 5, cotangent of theta is 5 over 13. This is true. Okay? Your brain is able to flip those ratios. The problem in this question and the problem that it poses to your brain is the fraction that's here is not the ratio at the end. It's the theta. And in our definition of cotangent theta, does the angle ever change? No, it stays exactly the same. So in order to get this right on my calculator, I'm going to have to go 1 over, and then I write tan of the exact same angle, and the angle that I have right here is 12 pi over 5. Oh, I used my calculator. Did you get, everybody was confused? And my calculator was? Degrees. But in my head, I just switched to radians, but I was using 2 different calculators. So now everybody was like, I'm making a mistake. The answer is 0.3249. Oh my goodness. Man, it's a rough day for me today. But you really paid, it was actually good. You really paid attention there. Everybody's like, I'm making a mistake. I better pay attention. 0.32. Good thing I showed you the right way to do it. Oh, you know what's crazy about this one? This is another place where students sometimes make what's called the double rounding error. I'll show you how the double rounding error works. Would you agree to the nearest hundredth that this is 0.32? Okay? But let's say you just were thinking 3 decimal places, because you didn't read the question first. So you first rounded to 3 decimal places. If I round this to 3 decimal places, I get 0.32. What number would I put there? 5. 0.325. And then if I looked at that and said, I need to round to 2 decimal places, what might you round to? 0.33. And then you would lose an E6 error for rounding because your final answer isn't right to 2 decimal places. That's called the double rounding error. Tricky.
How can we understand when we need to use degrees?
When to use radians? It's a good question. So how do we know that this question is in radians? We look carefully at the units that were given. And you see how they wrote? Nothing. That means radians. If it was a degrees question, there would be a degrees symbol there. One of the frustrating things with having no symbol. In fact, I know a teacher that is so mad with that, he put a degree sign with a little R in it. And then they use that as their radian sign. But the degree sign is so small that if you put a little R in it, right? And then if I was a student in that class, I'd be like, right? And they're like, is that degrees or radians? Oh, it's really small. Can't you tell? That one has a hole in it. That means degrees. And they're like, it's supposed to be radians. Oh, let me look. No, it does have a tiny R in there. Oh, I'd be trouble, eh? You wouldn't want me as your student. I'd be always like, planning, strategizing. All right. Questions for this one are not 7. The questions are 6 and 11. Questions for the first one were 4, 5, and 7.